Hello and welcome to today's lesson where we're going to look at the radiation and absorption required practical, which is part of the GCSE Combined Science topic waves. So in today's lesson we're going to look to understand how different objects emit radiation. So if we're successful and we learn in today's lesson, we can detail the process of emission and absorption. We can understand the emission and absorption rates of different objects, and then experimentally prove emission rates of objects and analyse experimental data, which falls into the following part of the GCSE Combined Science specification, properties of electromagnetic waves. So the following picture here shows us a Leslie cube. Now this is a cube with its sides painted different colours. So there's one side of the cube which is dark and matte, so you can see a picture of that here. There's another side of the cube which is dark and shiny, shown here. There is another side of the cube which is silver and shiny, shown here. And there's another side of the cube which is white and matte, which is shown here. So what happens is the cube is painted with the sides of different colours, and hot water is then placed into the cube and is allowed to heat up the cube. So the cube reaches thermal equilibrium with the hot water and therefore becomes an emitter of radiation. So in this investigation we're going to find the relationship between the colour of an object and the rate of infrared radiation emission. So if you're successful in this particular practical, you can find the link between the colour of a surface and its temperature loss. So what you'll need is the following. You'll need a Leslie cube and place it on a heat-proof mat. Fill the cube with very hot water and put a lid on the cube. You then use a detector to measure the amount of infrared radiation coming from each surface, which is done by measuring the temperature of the radiation emitted from each side. And you ensure that the detector is not in contact with any side of the Leslie cube, and you make sure the detector is the same distance from each surface, and you measure this value 1 minute after the cube is filled with very hot water. So you'll retrieve a kettle and use this to boil water. The kettle is filled to the maximum capacity before it is switched on. You retrieve your Leslie cube and you place your Leslie cube on a heat-proof mat. Now this prevents unwanted heat loss in the cube because the energy would leave via the bottom of the cube via conduction, but in this investigation we're measuring the heat loss via radiation. Now you'll then place a ruler against the edge of each surface and you secure the ruler in place with tape, so you can see it in these particular examples, and you'll do it for all 4 surfaces of the Leslie cube. You'll pour boiling water into the Leslie cube and place a rubber bung at the top of the Leslie cube, which will be there to prevent heat loss via evaporation. You then allow the sides of the Leslie cube to reach thermal equilibrium with the water, which should take about 3 minutes. You then retrieve an infrared thermometer, which then measures the temperature due to infrared radiation. It doesn't measure the conduction or the convection heat loss, only the infrared radiation heat loss. If you press the red button once, it measures the temperature of the object it's pointed towards. So you'll point it towards the surface you wish to measure. So you'll place the thermometer 10 centimeters away from the surface, which allows you to measure the emission of radiation, not the actual surface temperature. So again, it's important to note that the distance between the surface and the detector is a control variable in this investigation. So you'll receive your results as follows. So you always ensure the thermometer is 10 centimeters away from the surface and not touching the surface, because all the surfaces will be the same temperature because they're at thermal equilibrium with the water, but the temperature 10 centimeters away will be different. It'll be dependent on the amount of radiation emitted by that side of the cube. So you'll repeat the reading for each surface 4 times and calculate an average, as shown in this particular idea here. So what you then do is you'll fill in your results table with your observations. So you'll measure the temperature of the radiation emitted from the silver shiny side, the matte white side, the silver black side, and the matte black side. You'll then draw a bar chart of your experimental results, placing the temperature of radiation emitted on the y-axis and the side of the cube on the x-axis, and it will look something like this. And then the one with the highest temperature of emission is the best emitter of radiation, which in theory should be the black matte surface, whilst the silver and white surfaces are bad emitters of radiation, so they'll have a low temperature. Now, if we've been successful and we've learned in today's lesson, we can investigate how the amount of infrared radiation absorbed or radiated by a surface depends on the nature of that surface. So we can detail the process of emission and absorption, understand the emission and absorption rates of different objects, and experimentally prove emission rates of objects and analyze experimental data. So I hope you've enjoyed today's lesson on radiation and absorption absorption with the required practical needed in the GCSE Combined Science course for waves. Thank you very much for listening to today's lesson and have a lovely day.